This lesson is about expanding and simplifying binomial products. I'm going to use a diagrammatic approach to start with, and then we'll move on to an approach which doesn't require a diagram. If you have a look at this rectangle here, the length AB, the width of the whole rectangle, is A plus 3, and the length of the rectangle, BC, is A plus 5. So to find the area of this entire rectangle, we need to multiply the width by the length. A plus 3 multiplied by A plus 5. Now there's another way which we could find the area of this rectangle, and that's to look at each of these four areas in turn. Area 1 is A by A. It's a square, so it has an area of A squared. Area 2 is 3 by A. Area 3 is A multiplied by 5, so that's 5A. And area 4 is 3 multiplied by 5, so that's 15. So what we've shown here is that if we multiply A plus 3 by A plus 5, the result is these four areas added together, A squared plus 3A plus 5A plus 15. These two expressions are equivalent. And I can simplify this because 3A and 5A together make 8A. So a simplified expression is A squared plus 8A plus 15. I'm going to work through these 5 examples, but as soon as you feel confident, you should pause the video and try them for yourself before watching my solutions. In the first one, we have A plus 2 multiplied by A plus 6. And if we work out each area in turn, the first area is A by A, so that's A squared. Then we've got 2 by A, which is 2A, then 6 by A, and then 6 multiplied by 2, which is 12. And I can simplify by collecting the 2A and the 6A to give A squared plus 8A plus 12. In the second example, we have A plus 4 multiplied by A plus 2. And if we look at each area in turn, A squared, 4 by A is 4A, 2 by A is 2A, and 2 times 4 is 8. So again, collecting those like terms, 4A plus 2A is 6A, so this is A squared plus 6A plus 8. The third example is A plus 1 multiplied by A plus 5. A times A is A squared. 1 times A is A. And 5 times A is 5A. 5 times 1 is 5. And A plus 5A, that's 6A. So hopefully you've got the hang of this by now to be able to pause the video and do the last ones yourself. A times A is A squared. 7 times A is 7A. A times 8 is 8A. And 7 times 8 is 56. So this means that A plus 7 times A plus 8 is A squared plus 7A plus 8A plus 56. 7A plus 8A is 15A. So this is A squared plus 15A plus 56. By now you may have realised that we can multiply out the brackets without using the diagram, as long as we multiply each term in the first bracket by each term in the second bracket. For example, A squared, that's A times A. 7A is 7 times A. 8A is a times 8, and 56 is 7 times 8. So I'm going to use a method called FOIL, which stands for first, outside, inside, last, for this last example. We've got a plus 3 multiplied by a plus 3. This one is a square. So we multiply the first term in each bracket to get a squared. We multiply the outside terms, a times 3, then inside to get another plus 3a, and then the last terms in each bracket to get 3 times 3, which is 9. And then, as usual, we collect the like terms to simplify this as a squared plus 6a plus 9. And referring back to the diagram, this area here is a squared, 3 times a is 3a, another 3 times a, and then 3 by 3 is 9. But now we can see that we actually don't need the diagram and we can still get the same result. I quite like this FOIL method because for a bit of fun we can add some teeth and an eye and a fin, and this is a shark. So now I'd like you to pause the video and try these 5 examples using the FOIL method. And up to now we've only had addition in each bracket, but you'll notice that we have some subtraction and some negative terms. So we'll see if you can figure out what to do. Pause the video, try for yourself, and then watch my solutions. So in number 1 we have x squared plus 3x plus 2x plus 6, which is x squared plus 5x plus 6. In number 2 we've got a squared, and then because this is subtract 4 instead of plus 4, this is like a times negative 4, so subtract 4a. The 5 and the a are both positive, so that's add 5a, and then plus 5 and take 4. This is like multiplying positive 5 by negative 4, so this is subtract 20 at the end. Now when we simplify, take 4a and then plus 5a, we can replace that with plus 1a or plus a. Next we've got negative x multiplied by 2x, so that's negative 2x squared. Then we've got negative x, and notice is subtract 3 here, so this is like multiplying negative x by negative 3, which is plus 3x. Then 2 times 2x plus 4x, and then we've got positive 2 multiplied by negative 3, so subtract 6 and simplify. 3x and 4x is 7x. 7 times 3 is 21. 7 times negative 5m, take 35m. Negative 2m times 3, take 6m. And then we've got negative 2m times negative 5m, so plus 10m squared. And when we simplify, if we take 35m and then take another 6m, this is take 41m and then plus 10m squared. And finally, x multiplied by 2x is 2x squared. X times negative y, so take xy, then 2y times 2x plus 4xy, and then plus 2y multiplied by negative y, so take 2y squared. And simplify the xy terms. If we take xy and then add 4xy, this is the same as adding 3xy. I'm going to conclude this lesson with some special binomial products: the square of a sum, the square of a difference, and the difference of perfect squares. So the square of a sum means that we have two terms added together to make a sum, and then this sum is squared. Now remember, squaring is multiplying by itself, so we can write this out as a pair of brackets, a plus b times a plus b, and then using FOIL, this is a squared plus ab plus ba, which is the same as ab, plus b squared. So we can simplify this to a squared plus 2ab plus b squared. We had an example of a square of a sum, which was a plus 3 squared. So using the method that we just found, this is a plus b where b is 3, so it's a squared plus 2 lots of ab. In this case ab is 3a, and we've got 2 of those, so 6a plus b squared, which is 9. The square of a difference means that we subtract one term from another and square the result. So if we write it out as brackets multiplied together, this is a squared, take ab, take another ab, and plus b squared. So a squared, take 2ab plus b squared. So you'll notice that the square of a sum and the square of a difference both include squaring the first term and squaring the second term, but in the middle we add 2ab for the square of a sum and we subtract 2ab for the square of a difference. Now the difference of perfect squares only becomes apparent once we've expanded the brackets. This is actually where we multiply a sum by a difference. We multiply a times a is a squared, a times negative b, so subtract ab, then b times a is plus ab, and then b times negative b, take b squared. So subtract ab and plus ab, they cancel out, and we're left with a squared take b squared, which is why this is called the difference of perfect squares. It's when you have the same terms in each bracket, but in one bracket you're adding the terms and in the other you're subtracting. So I'll work through some examples, and you don't have to use these rules. You can always write a bracket squared as a bracket times itself and use FOIL as before. But I'll show you how what we've just done can make the process easier. So d plus 4 squared is the square of a sum. It's the first term squared plus 2 lots of the first term multiplied by the second term. So 2 times d times 4 is 8d plus the second term squared. Then we have the square of a difference. This is the first term squared. Take 2 lots of the terms multiplied together, so 2 times m times 3 is 6m, and then the second term squared plus 9. And finally, I can recognise that this is going to result in the difference of perfect squares because we've got the same two terms. One is subtract and one is plus, so this will result in the difference of perfect squares, r squared take 36.